Welcome to lesson 1.4, pairs of angles, angle pairs. The learning targets for this lesson are that by the end of the lesson you should be able to identify pairs of angles and different types of pairs of angles, and you should be able to set up and solve equations and find measures of pairs of angles. We begin with the first example, which is really example 0. You should be able to do these things on your own, so if you take a minute to pause the video, see if you can set up these expressions on your own. If you got these expressions for A, B, C, and D, feel free to fast forward the video to the point where you see a giant star right next to the term adjacent angles. If you didn't, stay tuned to see how to go over those. For the first expression, we have 4 more than twice, and it's more than, so it should come after when we see the word then, although for addition it's not as big of a deal because when you solve you'll still get the same answer. Twice a number is 2x. So we really have 4 and 2x and we're adding them, but because of the word more than, if it just said 4 more, it would be 4 plus 2x, but because of more than, the plus 4 comes after. For 6 less than, now this means we are subtracting 6, but it means we're subtracting 6 from something. If it just said 6 less, then it would be something minus 6. But when it is 6 less than, then we have to do the expression minus 6. Well, the expression that we're going to subtract or take 6 away from is half a number. So 1/2 times the number. Letter C, the difference of 4 times a number and 3. The difference of 4 times a number and 3, the difference of this and this, means that I'm subtracting 3 from 4 times a number, which is 4x. And letter D, the sum of 10 and a number doubled. So I'm supposed to take the sum first of 10 and a number and then double it. So there's the 10 and the number, 10 plus x. The quantity is in parentheses, times 2. All right, here we are at adjacent angles. Adjacent angles are 2 angles that share a common ray but don't overlap. In other words, there are 2 angles like we worked with in 1.2 that using the angle addition postulate can be added together to form a larger angle. The 2 by themselves form a larger angle. But it's very critical that we make sure we pay attention to this part, that they don't overlap. Because if they overlap, then we have a problem, then we can't add them anymore. So let's take a look at an example of this. Adjacent angles, angles 1 and 2 are adjacent in that they connect, they have a common vertex. So they share a common ray, they have a common vertex. So I probably should have put that they also have a common vertex. And they don't overlap, so all of angle 2's points are in here, and all of angle 1's points are in here. And so that part's good. And then they don't overlap. So here's an idea of one that would work. This one's good. Here's one that doesn't work. I have angle 1, and then I have this bigger angle in red. I'm not even going to name it now. We'll get to that in a minute. So my bigger angle has points over here and points all over here. And angle 1 only has points in here. Well, they are overlapping. The red angle is the larger angle, and it's actually overlapping the smaller one. So the black angle in this picture, this part right here, is where they overlap. That and the red are not adjacent. So those ones are not adjacent. All right, let's take a look at this picture right here. They ask for measure of angle 1 and measure of angle 2. Measure of angle 1 is these actually are something that we call a linear pair. We'll talk about that in just a second. But they are adjacent. And if I were to make this one, let's say 120 degrees, I should be able to figure out what this one is. Measure angle 1 is 120 degrees. It's obtuse. Measure angle 2 is a different angle. It's acute. And if I add them together, right, so here's my angle 1, and here's my angle 2. Notice there's their common ray, and they don't overlap. When I put them together, they form a much larger angle. That larger angle being this one right here. That angle is a straight angle. It is 180 degrees. So when I add the two of them, they should add up to 180 degrees, regardless of what numbers I assign to them. In this case, I assigned angle 1 to be 120 degrees. Well, 180 minus 120 is 60, so angle 2 has to be 60 degrees. We also have this picture right here. We're supposed to find the angles. I'm actually going to assign some angle values and ask you to see if you can find some of the angle measures. So angle T is 30 degrees. I've decided that we're going to make that one 30 degrees. I want to see if you can find angle U and angle X and maybe even angle Y. And to do that, you're going to be looking for linear pairs or adjacent angles that add up to a straight angle. And we'll talk about vertical angles in a minute. So pause the video, see if you can find those four values. If you did this correctly, you should have gotten that this linear pair right here, the 30 and angle U, add up to 180, so therefore U has to be 150 degrees. If you did this correctly for this linear pair, T and X, if they have to add to 180, 180 minus 30 makes X 150 degrees as well. And then if you took your angle from X with one of the other angles, maybe angle U, you'd have another linear pair there. Well, you already know the value of U is 150, so that means that Y has to be 30 degrees as well. T plus X, those add to 180 degrees, and X plus Y, those also add to 180 degrees. A linear pair is defined, we've identified them and used them in this picture. We actually used what's called the linear pair theorem, which we'll be proving at a later date. Linear pairs are a pair, it is a pair of adjacent angles whose sum is 180. Well, actually, that's not the definition. Hold on. Not whose sum is 180. That form a straight angle. So we can have adjacent pairs that are not linear pairs. For example, and you don't need to draw this, there's two angles, angle 1 and angle 2 are adjacent. But they're not a linear pair because to be a linear pair, they'd have to connect to make a bigger angle, to make a straight angle. And so those are adjacent but not linear. Vertical angles are actually present in the picture that we see above. They are angles that point to each other when two lines intersect, is how I usually define them. They're formed by the intersection of two lines, and they are actually across from or opposite of each other. So linear pairs, at least in this picture, would be the 30-degree angle and angle Y. Those are two angles that if you were tracing the angle, if I trace that angle and then I trace this angle, they actually point right to each other, and it turns out they will always be congruent as well. Notice angle Y was 30 degrees, and so was angle T. So vertical angles, there's actually a linear pair theorem that says that the linear pairs add to 180 degrees, or that they are supplementary is the word that we'll get to in this lesson. And vertical angles are always said to be congruent, or the same measure, as we can see in the picture above. And those are theorems that we'll be proving later. But for now, what you need to know is that they are formed by the intersection of two lines. And sometimes there's other lines that are intersected with them. So we have to be careful and look for the ones that are congruent and that looking only at the two lines, even though there could be more lines in the picture. Formed by the intersection of two lines, they're the angles that point to each other. And there is a theorem that says that they will always be congruent, and we'll be proving that later. All right, tell whether the angles are adjacent. So we're supposed to tell whether the angles are adjacent angles or vertical angles. If they are adjacent, then we need to state whether they are a linear pair or not. So we'll be tracing these angles to determine this. So I'm going to look at angle AEB. E is the vertex. I'm going to trace it right in the order that they give me, AEB, and angle BED. So in my other color, we'll do blue. I'm going to do BED. Those two they come together, and they are not vertical angles. They're not the intersection of two lines when they point to each other. This one is obtuse, and this one is acute. And the points in this space are separate from the points in this space. These ones would have been green if I had chosen the right color. So they are adjacent. They're actually more than adjacent. You can put ADJ to abbreviate adjacent. They also, if you look carefully, form a straight angle. There's the straight angle right there. So they are also a linear pair. So it is adjacent and a linear pair. You can use capital L point, capital P for the abbreviation of linear pair. All right, now we're going to go to the next one, AEB. Looking at angles A, E, and B, I'm going to trace angle AEB again. And I'm also going to trace angle BEC. All these points are in here. These points in AEB are in there. They may or may not be congruent. They don't look it. But the points are separate. They share a common ray, and they form a larger angle. So they are adjacent. But they do not form a linear pair because when I put the two rays that are not connected together, I get a larger angle, like I should with adjacent angles, but I don't get a linear pair. It does not form a straight angle. All right, let's take a look at this next one. We have DEC and AEB. These, although they do share a common vertex, and although the points on this one are separate from the points over here, they do not connect. They do not have a common ray. So, and they don't form a bigger angle. There's a gap. Because of this gap, and it not forming a bigger angle, these are not adjacent. And they're also not vertical angles. We don't have the intersection of two full lines with the angles pointing to each other. And lastly, for this example problem, we're going to look at BEC and BED. Now here's what we have. With BEC, all of its interior points are here. And with BED, its interior points, we have a problem. They're overlapping angle BEC. So because these are actually overlapping angles, these are not adjacent angles. Since they're not adjacent, even if they did form a linear pair, it wouldn't matter. They're not adjacent. Even if it made a straight angle, they would not be a linear pair, kind of like the last example too. Even though the bottom was a line, they're not actually adjacent, so they don't give you the full straight angle. It has a gap or a chunk missing. Please pause the video and try this for letter B. See if you, using this picture to the right, can identify some of those angles. Welcome back. Angle 5 and angle 6, if you looked at those very carefully and traced them, they do share a common ray, which makes them adjacent because there is no overlap, and they make a straight angle. So these are both adjacent and they form a linear pair. Next, we're going to look at angles 5 and 8. Angle 5, or TPU, and angle 8, or RPQ. Now, if I look at that, I see a big old X, and I should have pointed that out for our vertical angles. With vertical angles, you'll often see a big old X when you trace the angles, and they'll be the ones that are pointing right to each other. So you can see right here, I picked the wrong thing. Right here and right here, those kind of point into each other. We have the same thing going on here. Angle 8 is pointing to angle 5. So these angles are vertical angles. And you can put capital V, capital A for vertical angles. Angle 7 and angle SPU. So let me clean this picture up a little bit. Angle 7 and angle SPU, here is the tracing of angle 7. And here's the tracing of angle SPU. We have a problem in that SPU is the larger angle and angle 7 is inside of it. So these are not adjacent. And lastly, we have angles 7 and 8. Angles 7 and 8 at first glance look like they may form a linear pair. Here's angle 7, there's its ray. And here is angle 8, and here's its ray. So if you just look at those bottom rays, you're like, oh, I see a straight line. But they don't share a common ray. We have this gap in here, which means they don't actually form a straight angle. This is part of the straight angle, and this is part of the straight angle. But because of the gap, they don't form a linear pair, and because they don't have a common ray, only a common endpoint, they are not adjacent. Looks like somehow it got cut off on the screen, so we're going to look at the last two that I didn't ask you to do because I didn't realize they were there. RPT. Here's RPT, this whole angle and all the points in between, and angle 6. And so I'm going to trace angle 6 in green. Here's angle 6. Again, I see the letter X. Part of it's blue. Up here's the ends, and here's the ends of them. And I have this angle, and I have this blue angle. They kind of look to be about the same. They're pointing to each other with the intersection of two lines, so those are vertical angles. We're asked to look at angle 7 and angle 5. So looking at angle 7 and angle 5, angle 7 is here. Angle 5 is here. They share a common ray. If you put them together, you would get a bigger angle. So these are adjacent. They're a pair of adjacent angles.